What's up, everyone, and welcome back. If you've ever wanted to learn Python but felt like you didn't know where to start, or maybe you tried before and got completely overwhelmed, this is the video for you. I'm Bo Carnes from freecodecamp.org, and I've put together what I genuinely believe is one of the most complete Python courses for absolute beginners you're going to find anywhere on the internet. You might already know me from one of the most popular JavaScript courses on YouTube. I've also created a ton of Python tutorials over the years, but this course is different. This one is the full package. Everything you need to go from knowing absolutely nothing about programming to writing real functional Python applications all in one place. And here is what makes this different from almost every other beginner course you've probably seen before. We are not going to sit here and talk about theory for an hour before you write a single line of code. No, we're jumping straight in. Within the first few minutes of this video, you are going to be writing your first Python program. That is a promise. And here's something else worth knowing right from the start. You don't need to install anything on your computer to follow along. All you need is a web browser. We're going to be using a platform called Replit, a free online coding environment that lets you write and run Python programs directly in your browser. Replit actually provided a grant that helped make this course possible, and they make it incredibly easy to get started without any setup headaches whatsoever. Later in the course, I'll show you how to get Python running on your local machine if that's something you want to do. But for now, the browser is all you need. Here's how this whole course is structured. We start by building a complete rock, paper, scissors game. Right off the bat, a real project. Then we go deep into every major feature of Python, and I mean every single major one. And then we finish the whole thing by building a blackjack card game together step by step, with me walking you through every decision along the way. There's also going to be some intentional repetition throughout the course. That's not an accident. Repetition is how you actually lock concepts into your long-term memory, so don't be surprised when we revisit certain ideas more than once. It's there to help you. All right, let's get into it. Head over to replit.com and create a free account. You can sign in with a Google account if you want to keep things simple. Once you're in, click the Create button or the plus icon to start a new project. Make sure you select Python as your language. Replit supports a massive number of languages, but today, Python is our focus. Click Create and you're in. Let me give you a quick tour of the interface. On the left, you've got your file browser. In the middle, that's where you write your code. And on the right side, that's the console, where your program's output is going to appear. Simple, clean, and everything you need to get started. Now let's write some actual code. We're building a rock, paper, scissors game, and the first concept we need to understand is variables. A variable is essentially a label that you attach to a piece of information so you can refer to it later. So let's create our first variable. We'll call it player_choice and set it equal to the string rock. In Python, we write that like this: player our choice, chutter rock. The underscore between the two words is just a naming convention in Python for variables that have spaces in the name. The equal sign here is called the assignment operator. It's how you attach a value to a variable. And the quotation marks around rock tell Python that this is a string, which is just a word or a sequence of characters. You can use double quotes or single quotes, as long as the same type of quote appears on both sides. Now I want you to try something. Before I show you the next step, go ahead and try it yourself. On the next line, create a variable called computer_choice and set it equal to the string paper. Pause the video if you need to. Here it is, computer choice chew paper. Simple. You've now written your first 2 lines of Python. It gets more complex, I promise, but every complex program in existence is built from building blocks exactly like these. Now let's talk about functions, because functions are one of the most important concepts in all of programming. A function is a block of code that only runs when you call it. Think of it like a recipe. You write it once, and then you can use it as many times as you want without rewriting it from scratch. To define a function in Python, you use the keyword def, that stands for define, followed by the function's name, followed by a colon. Then everything that belongs inside that function gets indented 1 level to the right. This indentation is not optional in Python. It is how the language itself understands what belongs inside a function versus what doesn't. Some other programming languages use curly brackets for this. Python uses indentation. Get used to it, because it matters every single time. So let's wrap our two variables inside a function called getChoices. We type def getChoices : and then indent both variable lines underneath it. At the end of the function, we add a return statement, which tells the function what value to hand back when it gets called from somewhere else in the program. Now here's something important to understand about the code editor. You might see squiggly lines appear under certain parts of your code. If they're red, that usually means there's an actual error. If they're orange or yellow, it's just a warning, maybe telling you that a variable was created but hasn't been used yet. Don't panic when you see them. Read what they say and use them as feedback. They're there to help you, not scare you. To actually call a function, to make it run, you type its name followed by parentheses. So to call getChoices, you simply type getChoices with parentheses at the end. Let me show you this with a quick example. I'll create a simple throwaway function called greeting that just returns the string hi. Then I'll store what it returns into a variable called response. And then I'll use the print function, which is one of Python's built-in tools, to display that response in the console. When I press the run button, hi appears in the output. That's functions working exactly as they should. You define them once. You call them whenever you need them, and they give you back whatever you told them to return. Now let's talk about dictionaries, because we're going to use them in this game and you're going to use them constantly throughout your Python journey. Dictionaries let you store data in key value pairs. Instead of just having a list of items, you pair each item with a label that describes what it is. They use curly braces and they look something like this. Name map to bow, color map to blue. The word before the colon is the key. The word after is the value. You can use strings, numbers, variables. Dictionaries are incredibly flexible and powerful. In our game, we're going to update the getChoices function to return a dictionary instead of a single value. One key for the player, one key for the computer. That way, when we call getChoices, we get back everything we need in one clean, organized package. Right now, our player's choice is hard-coded to rock, which isn't very interactive. Let's fix that. Python has a built-in function called input that pauses the program and waits for the user to type something. We'll replace our hard-coded rock with that input function and pass in a prompt that says enter a choice, rock, paper, or scissors. Now when the program runs, it stops and waits. Whatever the player types gets stored in the player choice variable. Run it, type rock, and watch it work. Now your game is actually interactive. That's a huge step forward. Now, we need the computer to stop always picking paper and actually make a random decision. To do that, we're going to use a Python library. A library is a collection of code that someone else has already written that you can pull into your program, giving you extra functionality without having to build everything from scratch. We're going to use the random library. At the very top of your file, type import random. That one single line gives you access to everything the random library has to offer. Then we'll create a list called options containing the three possible choices, rock, paper, and scissors. A list in Python is a collection of items stored in a single variable, surrounded by square brackets, with each item separated by a comma. Then we set computer choice to random.choice passing in our options list, which tells Python to pick one item from that list at random. Now, every time the game runs, the computer makes a genuine, unpredictable choice. Rock, paper, scissors, completely fair game. Now we need to figure out who wins. We'll create a function called checkWin that takes two arguments, player and computer. Arguments are the pieces of information you pass into a function when you call it. Inside the parentheses of the function definition, these become parameters, which are just local variable names the function uses internally. To check who wins, we need conditional logic, and that means if statements. An if statement checks whether a condition is true, and if it is, it runs the code indented underneath it. One critical thing I need you to remember. When you're checking if two things are equal, you use two equal signs. A single equal sign is the assignment operator. That is one of the most common mistakes beginners make, and it will cause real problems if you mix them up. Two equal signs to compare. One to assign. Tattoo that on your brain. We check if it's a tie first. Then we check every winning and losing combination using elif statements, which stands for else if, and we use nested if statements and if inside another if to organize the logic cleanly and efficiently. Once all the win conditions are in place, we connect everything. We call get choices to get both choices, pull the individual values out of our dictionary, pass them into check win, and print the result. We also use something called f-strings, a clean, readable way to embed variables directly inside a string. Instead of messy concatenation with plus signs strung all over the place, you just put an F before the opening quote and wrap any variable in curly braces right inside the string. It makes your code so much easier to read. Run the program. Type your choice. Watch it play out in real time. You just built your first complete Python program, a real, working, interactive game. That is not a drill. That is actually happening right now on your screen. From here, the course expands significantly. We go deep into every major Python feature: variables, expressions, data types, arithmetic and comparison operators, Boolean logic, strings and string methods, lists, tuples, dictionaries, sets, functions, closures, classes, inheritance, loops, exceptions, modules, packages, and more. Every concept is explained clearly, demonstrated with working code, and reinforced with practical examples that naturally build on each other. One concept that trips up a lot of beginners is scope. Scope is the idea that variables can only be accessed in certain parts of a program, depending on where they were defined. If you define a variable outside a function, it's a global variable, accessible from anywhere in your program. If you define it inside a function, it's a local variable. It only exists within that function and disappears the moment the function finishes running. Understanding scope is not optional. Once you start building more complex programs, scope issues show up constantly, and if you don't know what's happening, they are incredibly frustrating to debug. We cover this in detail so you won't be caught off guard when it comes up. We also cover object-oriented programming in depth: classes, objects, methods, inheritance, polymorphism, and operator overloading. Classes let you create your own custom data types. You define what information they hold and what actions they can perform. Then you can create as many instances of that class as you need, and each instance keeps its own state completely independently of all the others. This is one of the most powerful features of Python. And once it truly clicks, once you really understand it, it completely changes how you think about writing code. It's one of those moments in programming where everything suddenly starts to make sense in a new way. And then comes the final project, Blackjack. We build the entire game from scratch using everything we've learned with object-oriented programming at the core. We create a card class that represents a single playing card, a deck class that holds all 52 cards, shuffles them, and deals them out, a hand class that tracks a player's cards and calculates the total value, including the special logic for aces, which can be worth either 11 or 1 depending on what helps the player most. And then we tie it all together with a game class that runs the entire game loop. It asks the player how many rounds they want to play. It deals the cards. It lets the player hit or stand. It has the dealer automatically draw cards according to the rules of the game, and it determines the winner after every single round. We test the game as we go, and here's something I want you to understand. When errors come up, and they will, we don't skip over them. We read the error messages, trace back to the problem, fix the code, and run again. That is the actual experience of programming, not having perfect code from the start, but learning to read feedback, debug problems, and keep moving until something works. That skill, right there, is more valuable than any single concept in this entire course, because every professional developer in the world spends a significant portion of their time doing exactly that. By the time you finish this course, you are going to have a genuine, foundational understanding of Python, not just a surface-level familiarity, but a real, working knowledge of how the language operates, how to structure programs, how to use functions and classes and libraries, and most importantly, how to actually build things that work. You'll have written 2 complete applications from scratch, and you'll have the confidence and the foundation to keep going from here into whatever you want to build next. Thanks so much for watching. If you made it this far, that already puts you ahead of most people who say they want to learn to code but never actually start. You started, keep going, and I'll see you in the next one.